Thank you very much, Sir Soren, and great afternoon to everyone. Okay. Yan. So again, good afternoon. I'm Leo. I'm an electronics engineer, and I'm part of the Power Electronics Laboratory of UP-EEI, and also the e-mobility research and development group of the same institute. So basically, our group, at least for our section, we basically deal with the electrification of transportation or land transportation. So later on, the next presenter will be discussing about the electrification of waterways or vehicles for our waterways. So for this presentation, just a short background. So back in 2022, so the EVIDA, or the Electric Vehicle Industry Development Act, was actually passed into law. So this law basically solidifies the effort of the Philippine government to support the transition of the country to renewable energy or sustainable energy vehicles. So the highlight of the law, as you can see here, it already presents a mandatory 5% of EV share when it comes to corporate and government fleet. So the law already mandates the transition of at least 5% share of our vehicles locally into electric vehicles. Because the main objectives also of the law is, at least for the transport sector, is to reduce our dependence on imported fossil fuels for our transportation sector. And together with the EVIDA is actually the CHRG, or the Comprehensive Roadmap for the Electric Vehicle Industry. So the CHRG, basically, it provides the flesh to the EVIDA in terms of the roadmap of the government, the specific action plans that the different agencies are going to undertake in terms of the implementation of the EVIDA. So specifically, the CHRG outlines the action plans for the EV industry, specifically for the electric vehicles and electric vehicle charging stations, the manufacturing, human resource development, and also research and development. So from our end, we work on number 4, which is basically research and development. And today, I will be discussing actually just the overview or the highlights of the program, especially through the NYSER e-mobility program and the electric public utility bus program. So the program is actually huge. So given the time, I'll only be able to discuss basically just the tip of the iceberg, just to give you an appreciation or overview of what we do. So basically, the NYSER e-mobility program is actually a collaborative effort through the collaboration of the Department of Science and Technology, UP Diliman, and the Cagayan State University. So on the top level, the program actually wants to design, develop, and manufacture local electric vehicles that can already be assembled and manufactured here in the Philippines. So I'm talking about the body, the chassis, suspension, the frame, and all of the electronics. As much as possible, the program wants to design and develop those vehicles locally. And for the NYSER e-mobility program, the part of UP Diliman is actually through Project 2. So we are basically in charge of the development and assembly and testing of the whole electrical and electronic system of the vehicles. Okay, so I'm jumping actually to the summary of this presentation for you to be able to already get a glimpse or an overview of the output that we were able to give for this program. So these are actually just 3 of the different prototypes of e-trikes. We call it electric tricycles or e-trikes here in the Philippines. So these vehicles are in a way unique to Southeast Asia or the Asian region because they are used for the so-called the first or the last mile connectivity. So the counterpart of these vehicles are what we call tricycles. So they're generally powered by gasoline. So for the program, again, we were able to develop 3 prototypes as an alternative for our tricycles. So these here are actually 3 electric tricycles. So the one on the rightmost, actually in collaboration with a local company called EVIDA. But for the first 2, the prototype 1 and prototype 2, these are actually holistically designed and developed from the ground up. So, and actually, just to also highlight, as you can see, the body composition, especially with Prototype 2, I just want to mention the team from CSU also implemented the use of abaca fibers for the construction of the body of these e-trikes. So basically, we also want to showcase and utilize our locally available raw materials for the production and construction of the body of the e-trikes. Already mentioned that because further down the presentation, we'll be only discussing about the electronics. So baka makalimutan. Okay, so if you're watching the news, of course, so lately, it became a hot topic here in the Philippines regarding the regulations on where these types of vehicles, whether you're using an e-bike, a tri-bike, or an e-scooter, in terms of road access, it was in a way a hot topic in the news. But actually, even before that incident, there are already regulations issued by the LTO in terms of the accessibility or road access that will be given to these types of vehicles. So for the vehicles that I showed earlier, these are categorized as L4 vehicles. So they are symmetrical vehicles. And L5 are the non-symmetrical vehicles that are also electric vehicles. So again, this is just a rundown of the restrictions and regulations when it comes to these types of vehicles. So for these vehicles, although motorcycle helmets are not really required, so appropriate driver's license and registration of the vehicles are still required. So just keep those in mind. Okay, so again, aside from the holistic design of the vehicles, on our part, the Project 2, we were able to develop the main electronic components of our e-trikes. So these are the three main, basically huge chunks of those components, namely the VCU, the BMS, and the motor controller. So for this project, we were not yet able to integrate a locally designed and fabricated motor controller, but that will, or motor, electric motor, but that will be addressed down the road. So basically, the VCU, of course, is the brain of the vehicle. It controls all of the vital functions of your EV. And the battery management system, by the name itself, it not only manages the battery, it monitors the functionality of the batteries, and then also provides a great level of protection for the batteries. Because for electric vehicles, especially the ones using lithium-ion, so the cost of the batteries constitute about 30 to up to even 50% of the vehicle cost. So that's why we really need to provide a safety and reliability when it comes to our batteries. And of course, for the motor controller, this is the one that converts power from DC to AC and drives the motor. Okay, so this is just an overview of the methodology and development flow that we are using. So so even before we go into the development of actual hardware, so these are the software that we are already using to basically design, simulate, and calculate the level of power, so the level of communications and complexity that we need to include in the design. And of course, for hardware and software implementation, so these are the software that are being used. For design verification, we heavily use ANSYS for this. And for when we already have the vehicle at stage 4, we do the testing and pre-certification of the vehicles for the components in PEL, but for the whole vehicle, we use the facility in EPDC, in Bicutan, and also in Tuguegarao, the EMRDC, or the Electromobility Research and Development Center. Okay, so as I mentioned from stage 1, so even before we do any hardware development, so the fancy term for this is actually digital twin, but we refer to this as the model. So even before we decide the CAD for the vehicle, even before we decide the level of power the size of the battery or the capacity. We do simulations and vehicle modeling inside MATLAB Simulink. So basically through this, we are able to already develop a digital model of the vehicle. So, and not only that, we are able to actually simulate also the road conditions that the vehicles or that the vehicles will be used. So we'll be able to, like for example, if it's going to be used in Baguio, where you have a lot of uphill, we'll be able to adjust the motor power and the battery size to accommodate that specific conditions. And this is just an overview of that package. So this is a very methodical process, even the integration of air conditioning. So we'll be able to model that and also see the effect of air conditioning to the vehicle mileage or efficiency. Okay, so for design verification, as I mentioned, we use ANSYS. So we use these two components heavily, the SI wave and the ice pack. So the ice pack, of course, for the thermals, so the thermal performance of the electric vehicle components. And for SI wave, we use that for signal integrity, especially for the evaluation of EMC for our PCB design. Okay, so when we already have the components, the prototype, also it's great that Keysight was able to present earlier and touch on some of the standards when it comes to testing. So we do, or basically we perform pre-certification testing for the prototypes that we are able to develop. So we do this in EPDC. So this one specifically is for the EMC testing or electromagnetic compatibility testing of the battery system and the BMS. Okay, we also do thermal and humidity testing. So we subject the components that, the prototypes that we did to extensive testing to high temperature and high humidity. And, ascertain that they will perform on actual road conditions and actual environmental conditions. We also perform ESD, or electrostatic discharge testing. This is basically high voltage testing for the components to ensure that they will not fail if ever a high voltage comes in contact with the electronic components. Okay, so as a whole vehicle, we also perform EMC testing, as you can see here. So we perform both radiated and conducted testing, both for immunity and emission, to ensure that the vehicles that we develop here are conformance to international standards. Okay, so aside from the EMC, ESD, and thermal testing, of course, we perform dynamometer testing. So even before we test the vehicles, the prototypes on the road, we'll be able to test it on the laboratory stationary setup. So we are able to get the maximum power, the mileage or the performance of the vehicles even before we deploy them on the road. Okay, so this is just one of the highlights of the laboratory testing that we did. So these are three graphs. Basically, the upper one is the no-load performance, and then the half-load, and then the full load. So as you can see here, we are able to characterize the performance of the vehicle in terms of its mileage. So you can see on the left-hand side, it's kilometers per kilowatt-hour. So the higher that number, the more efficient the vehicle is. So you can see here, we were able to characterize also on different speeds. So we are able to say on what speed you can operate your vehicle, and you will be able to get the optimal mileage out of it. Okay, so in addition to this project for the e-trike, currently we're doing another project with DOST again, and also CSU. We're doing the electric public utility bus project. So yeah, so same methodology that we applied, from design simulations to design verification and to testing. So this time it's a much bigger vehicle. So we're focusing basically on the vehicles that are used for public transportation. And this is just an overview of the specifications, target specifications that we are going to deliver for these vehicles. And hopefully, by next year, you'll be able to see this prototype bus either on EDSA Carousel or the Quezon City bus service. So I think that's it for this presentation. And I think in summary, we are doing the research and development efforts to basically design and bring the manufacturing of these electric vehicles here in the Philippines. So again, thank you very much and have a good afternoon. Thank you.
Thank you, Engineer Tayo. Are there any questions from the audience? Well, I have one question. Given the prototype, what do you foresee for the cost of the e-trikes, given that cost or price of the vehicle is a common source of contention for PUV operators?
Very good question. Actually, what we have right now is the prototyping cost. So typically for the electric vehicle, for the bigger model that you saw earlier, the prototyping cost for that is around 400 to 450,000. But remember that the prototyping cost is always high. Right now, the status of this technology is that we already have a licensed manufacturer for the e-trikes. So basically, if we get more number, we'll be able to bring the cost down, the manufacturing cost, and in turn, we'll be able to match or even lower the selling cost of the e-trikes. That will be hopefully in parity with the selling price of our conventional tricycles. Thank you.
All right, are there any other questions?
Yes, I have a question, just a general question. So you mentioned having a digital twin in your design process, and you've developed many generations of electric vehicles. I'm just curious how you also tweaked your digital twin as you have been iterating your prototypes. Does it generate its sensors within the simulation, or do you use actual sensor data to interface with your digital twin?
Yes, thank you for that. So again, we have, aside from the digital twin, we have the luxury of having the vehicle dynamometer inside the laboratory. So basically, we don't really need to drive the prototypes on real roads to get the actual data. So basically, what we do is do the actual testing on the dynamometer, collect all of the data related to that, and then we bring that back to the MATLAB model. And then we do the tweak, and we do the alterations on the parameters for us to be able to match, for example, the power curve, instantaneous power curve of the vehicle, and then the match also the mileage or the efficiency of the vehicle. And through that way, it's actually a feedback system that we can get from the actual prototype, and we bring that back to the MATLAB model.
Okay, thank you.
Thank you.
Are there other questions from the audience? If none, I would like to give this certificate of appreciation to Engineer Leo Alan Tayo for sharing their invaluable insight and work on electric vehicle prototyping and testing through the e-Mobility Research and Development Center during the NISCON 2024 conference, given today at Novotel, Quezon City, signed by Dr. Lou Andrew Tria.